Do you know, friends, that artificial intelligence is everywhere today? From Netflix recommending your next movie to self-driving cars detecting pedestrians to ChatGPT answering complex questions. But have you ever wondered what technology actually powers these intelligent systems? The answer is machine learning and deep learning. And the exciting part is we are going to explore about it in today's tutorial. So guys, if you are interested about it, then do watch this video till the end. Now guys, in this tutorial, we are going to start from the very fundamentals of machine learning, and then we are going to move towards deep learning concepts using PyTorch, which is one of the most powerful frameworks used by companies like Meta, Tesla, and OpenAI. You will not only understand the theory, but also see how to implement real models in the code, so that by the end of this tutorial, you'll have a clear understanding of how deep learning models are built and trained. Now, before we move on, here's the agenda of our today's tutorial. First, we are going to explore some of the fundamentals of machine learning. Then we are going to explore how to use PyTorch. After that, we are going to explore linear regression algorithm. Then we will deep dive into what are neural networks and how they power deep learning. And finally, we are going to explore convolutional neural network, which is also one of the most important algorithms of deep learning. Now, before we deep dive into the session, just a quick info for you. Simplilearn has got professional certificate program in generative AI, machine learning, and intelligent automation. You can transform your career with AI and automation skills, which is required by every industry. Also, you're going to get program certificate from IFHC, TIH of IIT Delhi, powered by Simplilearn, 2-day campus immersion at IIT Delhi, and IHFC Executive Club status. Also, you're going to earn Microsoft course completion certificate, and also you are going to get badges and trophies. This course is in collaboration with Microsoft. So guys, hurry up now and join the course. The course link is mentioned in the description box. Now, before we move on to the tutorial, here is a short quiz to test your knowledge. So guys, the question is, which of the following algorithms is commonly used as beginner model to understand how machine learning works? And your options are k-means clustering, linear regression, decision trees, or random forest. Please mention your answers in the comment section below. So guys, let's get started. Now, before we deep dive into deep learning, let us first understand why do we even need machine learning? So let me show you one example. Let's say we go to amazon.com. Okay. Let's say, for example, if a user clicks all over here, add to cart, okay, and the program is running like a rule. Let's say, add this product ID to this user's card in the database. Then, if you think on through the developer's perspective, they are trying to handle everything. Like, for example, what if the card is empty and the user clicks buy? What if payment fails, or what if the item is out of stock? For many such apps, rule-based coding works pretty much fine. If you clearly write rules for most of the situations, then you usually don't need machine learning at all. Now, where does this machine learning or deep learning comes into the picture? Then the good thing is the problems where rules don't work well. Now, think of problems like, let's say if somebody is asking you, predict tomorrow's weather using satellite images and past data. Then you have to do something called prediction. Or let's say if somebody asks you, detect all the people in an image and draw boxes around them, then you will be using this. Or if somebody asks you that recommend product that a user might like but won't easily find on their own. For these tasks, writing rules is extremely hard because patterns can change over time, like weather trends, user choices. And here the relationship is also too complex, like pixels identifying to a human face. Humans can do it easily, but we can't explain the exact rules to the computer. And for these kind of scenarios, machine learning actually fits well. Now, what exactly is machine learning all about? So, it's kind of a technique where you make your computer learn from experience, for example, data. So instead of hard coding the rules, we give the computer lots of examples of data. And for example, here we give correct answers for those examples. We try to label them in most of the cases and let the system learn from patterns on its own. And over the time with more data, it becomes better. A simple example I would like to tell you, for example, everyone would be using their phone, and let's say you use iPhone and you ask your Siri or any Amazon device where it has Alexa. Now, when you say, "Hey Siri," what happens, guys? The phone starts doing multiple machine learning tasks quickly. It detects the wake word, "Hey Siri," then it converts the speech into the text, and it then understands your meaning or the intent. And it gives the result. Maybe you would be asking about map routes or time prediction. So there's one good thing that I would like to say. If I say something like this, how would you write a rule based program to, let's say, detect Alexa? Okay. Now, your microphone collects around 44,000 sound samples per second. And what rule will always detect that one word correctly? So, for doing these kind of tasks, we need machine learning, or we can say we need deep learning. So, basically, deep learning is a subset of machine learning. Now, let me also explain you what is the key idea behind this. So, instead of writing a program that directly detects Alexa, we create a flexible program with many settings, and these are called as parameters. Then we feed the data to the learning process so that it can find the best knob settings. Then we adjust parameters, which are just like adjustable numbers, and it actually fine tunes the model. And if we talk about what is a model, so model is the program after the parameters are set. And then you talk about the model family. Then we have something called as learning algorithm, where the method that finds a good parameter settings using the data, which actually fine tunes your model. And then you have something called as training loop. Here's with the help of this how the model learns. So training usually looks like, let's say if you start with a random model, let's say it might be bad at first. You might give some examples such that you give a audio plus label, and let's say you give a weak word like "Hi Siri" or something like that, based on the previous example that we were discussing. Now you have to adjust those parameters so that it performs better. And you repeat it as many times until it becomes good. So instead of programming with rules, we are programming with data. And in today's tutorial, guys, we will be exploring the same. Now, let me show you what are the four building blocks that makes up our machine learning or deep learning model. So basically, no matter what the problem is, there are basically four things that you need. So first of all, I would say you need data. Okay. Then you need a model. Now, what is model, guys? So if I talk about model, model is a system that basically turns input into output. Then you need something called as objective function or a loss function. Basically, this is a score that says how wrong the model is. Then you need an optimization algorithm, guys, which basically tells you that how we improve the model or how do we reduce the losses. Then you have something called as features and labels. Now, when you get the data, you have to create the features and the label which you are going to feed into the model. So if I talk about features, this is something called as input information, like what do you exactly know about it. And label means the output answer, like what do you want to predict. For one good example, like I would say, let's say we have an image. Okay. Let's say we have an image of a cat. Now, if I talk about this thing, so you can call this as features. Okay. Now, let's say you want to label it as cat. Okay. But you're not telling your system that this is a cat. This looks like something. You will tell some features or information about it. And if you see that kind of image, you're going to label it as cat. So similarly, we have to work with the given thing. Another example I would tell you, like, let's say if you're working in a healthcare scenario and let's say this is a patient and you are giving some details about the patients. For example, it could be like their blood pressure or what is the sugar level and all those things. So you can just call it as the respective features. And let's say what is the survival time in 30 days. Let's say if the patient is under some critical condition or suffering from some critical disease, so you're trying to predict what is the survival rate. Let's say how much is the probability of the patient surviving in 30 days. Now this is what you are looking for. This is the output. So this becomes your respective label. Now guys, also very much important for us to understand that good data matters a lot. Because if you consider this analogy, if you put a garbage in, then you also get a garbage out. Meaning that if your data is bad, you're going to get bad result, or your model will not perform better. And let's say if your data is biased or has some missing values, your model will become unfair. Now, if I talk about model, guys, model is basically a machine that takes input data and produces predictions. So for example, let's say if you have input data and you feed this into the respective model, then whatever the predictions you are trying to get, for example, let's say if we look on to this given case study, okay, what is the survival days in 30 days? So that will be your respective prediction, and this is your model which takes up the input data or the patient detail, studies the feature, and based on how you train the model, the respective predictions are going to come. Now, let us also discuss a bit about the objective function, guys. So this is also very much important because we have to also make sure that how much wrong is our respective data, how we are going to judge the model. So we need a way to measure how good or bad the respective model is. And this respective measurement is called as objective function or the loss function in common name. Now, there is one thumb rule for this. The thumb rule is, let's say, if you have lower loss, okay, then you have to understand your model is very better. So your objective is that you have to lower this respective loss all over here. Now, let us also discuss a bit about regression all over here. Okay, so regression is a mathematical technique, or you can call it as a statistical technique, basically used in stochastic processes, and where you are trying to predict something. Okay, let's say the best example is the linear regression thing, or the linear regression algorithm, which you basically use in machine learning use cases. For example, let's say if I'm trying to predict the house prices in this locality, then for that purpose, we will be using regression all over here. We will be trying to predict what will be the price in the respective locality, and we give the input x values, as x is the input features. For example, like what is the locality, what is the city, what kind of house you are looking for, and based on that we will try to give the prediction. Now for that we use a mathematical technique called regression. So you have to predict the numbers, and which you mostly use a mathematical technique. So the given mathematical equation becomes y equals to mx plus c, where m is your respective slope. So that's the respective thing you try to do it. So regressions, there are multiple type of regression techniques, but in very short terms, I would say this is a statistical technique, okay, which is basically used to do the prediction. Now, there are also very important thing to understand about something called as classification. So if I talk about classification, this is like predicting the category, okay? So guys, there are a lot of classification algorithms like the clustering algorithms, and where we basically create the clusters, and let's say we try to put it whether this belongs to category A or category B. Now, one of the very good example of the classification problem is, let's say if I give you a sample of animals, and out of which I want to, let's say there are only two animals, let's say dogs and cats. And let's say I want to make a cluster of animals, let's say whether this is a dog or a cat based on the given data whenever you see. So for that, classification techniques are very much important. Then you will also find these concepts of overfitting, guys. So it's a very important concept with respect to machine learning, and you would be using this across in deep learning also. Now, sometimes, a model becomes great on training data, but it actually fails on new data. Now, that thing is called as overfitting, where we have to split the data into training set, okay, where we want to make our model to learn, and then there will be a test set to check the real performance of the model. So this is very much something like a practice exam versus the final exam. So overfitting is something like as we can deal with, you know, you have to split the data into training data, and also, so you have to check how your model fits to the overall scenario. Like it should not be overwhelmed on the training period and do not perform well on, let's say, real-time data or the test data. Then let us discuss also about optimization, because we will be optimizing our algorithms. Uh, so optimization is a technique, or you can say, where we actually do the training to improve the model. Now, the overall objective I already told you guys, to reduce the loss. So we use algorithms like gradient descent, where we actually try to reduce the number of errors or the loss function all over here. Basically, it checks which direction reduces the error, and then it adjusted the parameters slightly in that direction. Now, I will also discuss some of the machine learning types also. So if I talk about the ML algorithms, it can be divided into supervised, unsupervised. Okay. Now, if I talk about supervised, which is kind of most common use cases, let's say if you have inputs plus, correct answer. So basically, if you try to give labels to your given input, and then you are training your model to basically predict based on those labels which you have given, those are called as supervised learning. So you have to give input, and then you have to also give labels along with that, and after that you will be doing the prediction. Now, one of the most important use cases of supervised learning you would see is a spam detection. For example, let's say you might be getting thousands of email which are classified as spam if you look into Gmail. Now, this technology is actually incorporated in your Gmail, where what it is being done is that your Gmail is actually being trained with respective labels on the input data, how to classify whether some mails are spam or not. One another example you can also take up as a disease prediction. So there you give the patient detail, you label at, okay, this is the particular disease with these features. So guys, these were some supervised learning problems. Now, let me also explain you some of the unsupervised learning scenario. Now, what is unsupervised learning, guys? Let's say if I don't give any label with the input data, I just give you an input or an unstructured data. And let's say I would give you the respective goals, like you need to group similar items, or let's say you need to find hidden patterns, or let's say if I ask you to reduce dimension as we do in principal component analysis, or you have to learn embeddings like mapping things into vectors. So those things fall under the unsupervised learning. So we'll see those problems also, but you're not giving any respective labels as you are trying to give in supervised learning. Now, there is also one other scenario, guys, which I would like to discuss with you. That is called as self-supervised learning. Now, this is also becoming kind of very much popular in today's scenario. Now, in this given thing, I would suggest that no manual labels is required, but the model creates its own label through learning. For example, one good thing I would like to tell you, let's say I give the task, predict missing words in a sentence. Then how many modern language models are able to learn those things? So that comes under the part of self-supervised learning, where the model is creating on its own. It gives its own learning based on the given data. You don't provide any manual labels, or you don't give any labels to the data. So that's called self-supervised. So model takes and learns on its own. Now, let's also talk a bit about reinforcement learning. That's also pretty interesting type. So here, the model is an agent that takes actions in an environment. It learns using reward. For example, let's say if the model does the right task, you give the pointers, let's say positive points, or you give it reward. If let's say model corrects rightly, then you give something called as rewards all over here. And if the model does not predict correctly, what you give is punishment. Okay, so that's called as you know you can call it as negative rewards. So in this kind of scenario, we actually deal with reinforcement learning. So if you look onto the robots, let's say if the robot starts doing any wrong thing or it does not able to follow your instruction, so you give negative points to the model, and based on that you try to train a respective robots. Now all these robots which are used in the manufacturing industry to follow any process, they are trained using the reinforcement learning. And this is also a very special type of technique where you are very much interested about training a robot. Now these were some of the very important machine learning concept, guys, which we will be required to do it while we are doing deep learning. Now you would be asking this question that why deep learning is becoming so popular recently. See, the reason is deep learning has improved rapidly because we have huge data set. If I actually quote you the recent study, so you can see there are petabytes of data available with respect to all the industries there. So combined together on the internet, and the data are coming from internet, sensor, and with the apps which has millions and millions of users. So for that purpose, guys, if you are trying to train those data and try to understand a user behavior, so you need a powerful GPU, means faster training. You need better frameworks. So we have Python-based frameworks like PyTorch or TensorFlow. And with the help of deep learning, there is the reduced need for manual feature engineering. And it learns useful features automatically from the raw data. And that's why, the deep learning has become very much popular. And it is an extension of machine learning. It is a kind of very much important in those scenario where we deal with neural networks and we try to do very much in-depth prediction, or we try to study the data in a lot of ways. And there are special type of problems which could only be solved with deep learning. So you would have heard about, the autonomous vehicles who could drive it on its own. So there is a very important deep learning concept that comes into the picture. So the computer vision with which it able to identify which route to take. So guys, self-driving or autonomous vehicles are one of the biggest use case studies of deep learning, because it is taking like how we can train the respective vehicle to drive on its own, take intelligent decision, understand the traffic. So, with rule-based programming, you can never ever do that. And for that, we need techniques like machine learning and deep learning. Now, one of the biggest takeaway what I could give it to you, that if a problem can be solved with clear rules, normal programming is enough. But if the rules are too hard to write, but you have a lot of examples on it, then you will use techniques like machine learning or deep learning, because these are going to help you to learn the data and understand the respective features. Let's say the data could be type of image, audio, or it could be a language. So guys, I hope so you have clearly understood these respective concepts, which are kind of the building blocks of the deep learning. And let us proceed to the next part and try to explore some of the more interesting things. So guys, before deep diving into deep learning, let us try to explore a bit about linear regression, because this is one of the most important algorithms which will help us to understand how predictions actually work. Now, let me give you a case study. Imagine that you want to predict the price of a house. And if we talk about its features, the input is area and age. And if we try to look into what is a target label, and the thing which we want to discuss is what do you want to predict? Basically the price of a house. Now, if you want to look at the training set, which we can consider as a collection of the past house sales, which is used to teach the model. And the model is working on a guessing rule. where we assume that the price is a weighted sum of the features. In maths, it just look like something like this, guys. Let's say if we have y as an output, okay, let's mark it as output, and let's this equals to a thing called at m. M is a gradient descent all over here, which is basically the slope, okay, and let's x call as the input features. Basically it could take as the area all over here, and plus let's say c, and c is the extra constants that are affecting our respective parameters. Now this given equation is just a straight line with an intercept. If you put x equals to 0, then you get c as the given intercept all over here. So it's just a straight line, with its intercept on, let's say if I put x equals to 0, then y equals to c all over here. So this is a mathematical relationship, guys, all over here. But this is a very important equation which will tell us how much each features affect the price of the house. And let's say we could consider c as a starting price all over here, where if you put x equals to 0, what could be the minimum price that we could have? So this is the requestive mathematical equation for prediction. Let's say if you are trying to predict through linear regression algorithm. Now in deep learning, we use these things to make it much more cleaner. So we will use a vector notation all over here to simplify our given estimate. But the biggest question lies on this equation is that how do we measure error or the loss function? So we always want our prediction to be actually accurate. And to improve the model, we need to know how wrong this given equation can be or how wrong the given model can be. So what we do is we do the squared loss thing all over here. So the given thing that we actually include all over here is this given equation. So basically what we talk all about here is, let's say y is our the given outcome value that we are getting, okay, or we can also consider this as the given output value or the predicted value. That will be the correct term. And if we subtract this from given actual value, then this estimates our respective error. But the loss function is actually the square of this given thing, okay? So we can just do the square of this, okay? And this is what we are actually interested when we are trying to do the prediction to estimate how our model is wrong all over here. So in nutshell, this is all about linear regression, where we are trying to make sure that all our errors are positive, so that this equation, nothing we get out of negative. That's why we have got the square value. Now, one of the great questions which you could ask all over here from this given equation, how does the model learns? Okay, so we can guess the right weights that we have used. So right weights would be the x value that how we are calculating with the input features. So x is actually the real value where we are putting the input features. It could be, let's say, house of the price, the age parameter, or let's say which locality we are living in. So all this x value comes up as the weight. So x is actually, you can call it as something like this. In the mathematical format, it could be like wn x1, okay, plus this is basically the dot product that we are using, okay, all over here, plus w2 x2, and it's gonna go on till the input feature for each of the respective weights that we are trying to calculate. Now the most important thing is to calculate the gradient. So m is our respective gradient all over here, which actually tries to tell us that in which direction our correct prediction we are going through. So that's why we are trying to actually look onto this given factor. Now, as you move deep into the deep learning, you would also understand why vectorization actually matters. So in Python, doing math inside, let's say, a for loop is very slow actually. If I try to implement this logic with the help of for loop, it will be very slow. So we use certain libraries with the help of Python. So Python has got tons of deep learning libraries, and one of them is PyTorch. With the help of this, we do the vectorization method, okay, to actually do our processing of the computation very fast. Let me show you one good example where I'm going to use a PyTorch library. So let me show you what exactly PyTorch is. So if you want to learn about PyTorch, guys, or you want to take any reference, so this is the official documentation. You just type PyTorch and official documentation, just click on this and you see the symbol. This is the exact website of the PyTorch, and here you will also get the idea like how you can install the PyTorch, what is exactly PyTorch all about. So there is a one reference video also, you can look at to this, okay, and you will study a bit about tensors and all those things. But let us try to implement this on Google Colab, and let me show you how programmatically we are trying to implement this given thing. So first of all, I would like to install PyTorch in Google Colab. So guys, you need to type something like this. There's an exclamation mark, then you have to use the pip command all over here, and with the help of this you have to type install torch, then torch vision and torch audio. Let us click the enter and let our Google Colab connect to the Google server all over here, and let's wait for the green signal that it has already installed it, and then we can import the torch and we can use some manipulation actually all over here. So guys, you can see all over here that our requirement is kind of satisfied, and we can proceed all over here. Then let us import the torch first. Okay, so let us type torch. Okay, and let us also import time also, because that will be a very important factor in our calculation. Okay, which is just coming from the PyTorch library. And let us give something like let's say n equals to, let's say, 1000, and let's also declare two variables which we'll use with the help of, let's say, a and b. So let us declare this one variable a, and we could call it as torch dot once, and we can put n all over here, such that the input parameter is 1000 with respect to the a variable. And similarly, we could declare the value b also all over here. We could call it as torch dot once, and we could also use the same parameter n. Now let me show you one method which is a very slow process for the computational process, which is basically the for loop. So what you do all over here, let's say if I try to calculate the value of c all over here, then we could keep it like torch dot zeros, and here let us pass the value n all over here. Then let us calculate the time, and we could keep it as t equals to time dot time. We'll use a time function to calculate the time. Then let's say we are using the for loop in this given scenario, and let's say if I try to write for I in range, and let's say I take the value n, which is basically 1000, so it's going to loop through 1000 amount of time. And let us take this one given calculation all over here, where I just say c of I equals to a of I and b of I. Okay, just a very simple calculation, guys. And finally, we are trying to print the respective thing. Okay, so what we could do is we could, let's say, if we are trying to create some random data all around here, so we'll try to use a print statement, and let's say print f. Okay, and this say for loop time, and we could actually call the time function all over here, and let's say time is to time. So guys, this is the respective thing what we are trying to do. There are some errors in this. Let's try to resolve it all over here. So let's say if this is the respective formatting that we are trying to do, so we need to close it also. or rather we can just remove f over here, and let's say for time to time, and then we're calling this respective function. But the problem is that we have to also include this thing all over here inside the respective thing. So guys, if you could see in this given equation, we are using a very slow computational process where we are trying to create some randomly data all around here. Now, if you try to use the vectorization process, it's very much easier all over here. So what you're going to do instead of doing this, let me comment it out for you. So guys, let's say we declare another variable t where I'm going to store time.time. And let's say we create one more variable, let's call it as d, okay, and let's call this as the sum of a and b. Let's correct our indentation all over here, and after this we try to print the respective time data. So that's the respective thing. Now if you look into this respective thing, guys, this is going to be faster than the for loop. The reason is because the computer's GPU handles the entire addition in one instruction rather than checking it back with Python for 10,000 times or 1,000 times. So that's why we need to use the vectorization method all over here. Now, how does this connect to probability? See, if we could look into back again, we did some measurement regarding to the squared error. Okay. So there is a mathematical reason for that. Let's say if we assume that our data has a noise or that follows a Gaussian distribution, or we can say a normal distribution, then it's minimizing the squared error in the exact same thing as we're trying to find out the most likely weights available with respect to the x value that I showed you all over here. Now guys, in this exercise, we are going to generate a synthetic data set of house prices using PyTorch library, which is one of the most important libraries we use for a deep learning algorithm. So guys, in this problem, we are going to assess these features. So while predicting the houses, what we are going to do, guys, we are going to take these features, for example, like size. We are going to take features like number of rooms. Then we are going to take feature like age of the house, okay, to implement linear regression using a PyTorch library, which is one of the most fundamental libraries when you deal with deep learning algorithms. Now, let me show you how you can do this fundamental ML problem with the help of this. So first of all, let us try to do one thing. Let us try to install PyTorch. So you already see I have already installed PyTorch using this command pip install torch, torch vision, torch audio. Then we are going to generate a synthetic data out of it. So our first step is generating the synthetic data. So with the help of this, we are going to train a linear regression model. So guys, our respective command is pip install numpy, matplotlib, and torch from torch vision and torch audio. So deal with also any let's say if we are getting any other files or any other data set, PyTorch will be able to easily handle all kind of data set. So now we are going to import also the NN module, guys. So after installing this, let us try to run another command all over here. So let us try to import torch as NN module. So import numpy as np, matplotlib.pylot as psp, and we are going to import torch.nn module all over here and as nn. Okay. Then what we are going to do, we are going to import sklearn model also all over here, where we are going to train, test, and split our respective data. So let us type this from sklearn. Okay, and dot model, and we're going to put it as model selection all over here. So let's say from sklearn model selection, import train, test, and split. So this much works fine for now. We are going to not use these respective things. Okay. And after this, the next step is generating the synthetic data. So for that, NumPy is very much effective, guys. If you are not aware about NumPy module, so just go to all over here, and type in NumPy official documentation. And this is the official website of NumPy documentation. And you can look at NumPy 2.4, which is the official documentation of the latest version. And here you can have some of the basic idea, like how do we declare n-dimensional array, or how do we deal with scalars, and what are the data type objects, or what are data type promotion in NumPy. These are very fundamental concept, guys, and if you are a little bit not aware about these things, so what I would say is look onto the respective thing. Okay, look onto the respective module all over here. And we have also our some of the videos on our respective channel on NumPy. You can watch those videos to get a fundamental idea how to use this Python libraries, because all for these prediction tasks we use mix of these libraries. And for generating the random data all over here, NumPy is kind of very much important. So let us try to generate the values for the respective feature of our house prediction. So I'm going to use np.random function. Okay. And you can see it shows random. And let's say some seed value. Let's say we put some seed equals to 0. Let us try to put this value. Okay. And then the PyTorch library that we have to use, we can also try to add some seed values over here with the respective the torch library from the PyTorch. So torch dot, let's say it becomes manual seed, because this is a manual intervention, guys. And let's say the value is seed of 0. Now, the question next comes is, what are the number of data points that we want to use? Let's say for this given example, since I am trying to do a prototype of house prediction, I'm going to take the sample of 500 data points. So you can declare that respective values. Let's declare and sample all over here. And let's say this equals to 500 all over here. Okay. Now let us try to declare the size of a respective thing. For that also, I'm going to use a randint function. So declare how on the respective sample size is going to look like. So let's declare size equals to, for example, torch all over here, torch dot, let's say randint. Okay. And let's take those values into 1000 and 5000. Okay. And in this, what I'm going to use this n samples that I have declared. Let us pass these respective value in this respective argument. And also, let us try to use one as the respective argument all over here. Okay. Now, in this respective code, I'm also going to use the data type that I'm using. So let's say the data type that I'm using all over here, I'm going to use it in the float value, and let the size of the float be 32 bits all over here. So d type, let's say this equals to, for example, torch.float 32. Okay. So you can see our respective thing is already suggesting this thing from the Google Colab, because Google Colab is already equipped with AI. And these are very set problems to understand how to generate the synthetic data. Now, the next thing that we want to do, we want to actually estimate the size in square feet. So let us take one variable all over here, room. Okay. And let's say this equals to torch dot randint. And here, let's say this arguments are 1 instead of 5. I'm going to give it 6 as one of the argument, and I'm going to take n samples all over here and this value as 1. And after that, the given data type that I'm using is a float value of 32 bits. So this is the respective thing. Now, this thing we have already done. So the problem here it's showing is because we have put some extra parentheses. Now our given problem is resolved because we have removed this parenthesis, which was actually not required, because in this given features that we are trying to declare, we have to also look when we are working with the PyTorch library, we need to definitely include the data type all over here. And after this, let's try to declare the age as one of the features. So I'm all over here, I'm just trying to declare some of the features that I'll be using in my respective programmatic way to declare what are the features that I'm going to input in my respective model. So let's say this equals to age, and here let's try to incorporate the same function, which is a rand int function, which is very important when you want to generate some of the random values. So let's say age equals to torch.randint, and let's say this is 1, and instead of 50, I'm going to put it as 100 all over here, and let's take it as n samples, okay, and 1 as a respective argument, and let's say data type is also float 32. So which is going to predict the age of the respective houses. So I'm taking these 3 parameters, guys. For size, I'm generating data. For rooms, I'm generating the respective data. And for the age also, I am generating the respective data, which is done using the PyTorch library. Now, also let us try to add some of the noise in the data, because the real world data, whatever you are going to get, will not be accurate. There will be definitely some of the fluctuations in the data, and we deal with the respective word called noise. Okay, so how to add some noise? Very simple, just declare one variable for our given reference, and let us call as noise, and let us say this is equal to normal rand n function, and all over here we could take the n samples, but after this let us try to multiply this with 5,000, or let's say 50,000 of the respective noises in my data that I'm trying to get. Now also after this, I'm going to do what, guys? I'm going to add some random noise to the price data. So our price becomes, let's say this is the price value, this is 200, and let's say this is respected to our sizes. So 200 dot let's say size, and let's try to add some respective value, let's say 1000, okay, then into the respective rooms that I'm trying to get. So let's multiply that value. This is a bit of a mathematical calculation guide, but this is pretty much accurate all over here. And after this, let's try to subtract this respective value, the noise data, because that's kind of very much important to calculate the respective price. So 200 plus size into 1000 minus rooms minus 5000, okay, and we can multiply with the respective age, and we could add some noises. Now you'd be wondering about this mathematical equation, that how am I trying to detect the price? Very simple, guys. This is one of the most simple simulations. So what I'm trying to do is, let's say whatever the size is there, I'm multiplying it with 2000. So whatever the rooms I have, I am trying to multiply it with 10,000, and I'm trying to subtract 5,000 all over here, and then multiply it with age, and then I'm trying to add some noise all over here. Then after we have calculated these respective features, I'm going to stack these features together. For example, the size, the rooms, and the age. And we're going to put it all these values into the x parameter, because the equation which I told you was y equals to mx plus c. and x is the calculative of these respective, or we can say mathematically the dot product of these respective features that I'm trying to get all over here. So what I could do is, let's try to calculate x all over here. So let's say x equals to torch.cat. We are going to use concatenation, and let's say I'm trying to add size, room, age. Okay, and let's try to give a dimension. So one is basically, here is the dimension as a parameter that I'm using. So this is a one-dimensional plane where I'm trying to study about, and all over here, if you could see, all these data are one dimensional. That's why you could see the 1 1 values that I'm trying to write all over here. So let's also declare this given thing, and after this, let's say dim equals to 1, and after that I declare this variable y equals to price. Now in the next step, what we are going to do, we are going to split the data into training and testing set. So for that, we need to declare this respective variable x hyphen train. Okay, let's keep it as x train, x test, y train, y test. So I'm splitting the data into training data and the testing data. That's how our model works. So let me give you a little bit theory about this. So let's say if this is our x input value, and let's say this is our data. So first of all, data is actually split into two types. What we call it as the training data, okay, and next one is the testing data, from where we are going to make the predictions out of it. So first we train the model, then we test the model on some of the data which are not used in the training set to actually test the model's accuracy, and then we feed this thing into the model, and then you get the respective output. So this is kind of a pretty much very simple thing which we are actually working out with, let's say, machine learning algorithm, because the equation is pretty simple, y equals to mx plus c. So everything is whatever we are dealing with, the data is in one dimension. Now after this, guys, what you need to do is, let's say x train, x test, y train, y test, and after this we could use something like that, like train dot split. And here let's try to modify some of the things all over here. So in this split state, we could add x dot numpy, and we could use this respective function all over here, and we could also use something called y dot numpy. And let's say the test size that we are getting, we could keep this parameter factor as 0.2 and give the state, the random state of this as 42. So these are some of the arguments that we actually use all over here when we are trying to actually work with the deep learning algorithm, because this is very much important. And if you feel like some problem with these variables, I would like to ask you to explore these respective libraries, because these are very much important in this respective context. Now let us convert this numpy arrays into the PyTorch tensors. So what I could use is, all over here is, let's say we have x train feature, and let's say this equals to torch dot let's say tensor, and we could use x train, and here after this we could declare our data type, which is going to be in the float. So let's say this is a respective float of 32 bits. Then the training data set we create into the tensor of this, and we split into x test data set that we have declared all over here. And let's say the data type for this respective thing is also going to be of 32 bits. And let's say after this, we are trying to curate the y output value, or the output on the training data set. So for that purpose, guys, what I could use is the y train variable all over here, and I could use torch.tensor and then y train, and the data type is of 32 bits and of float. Also, guys, after this, what one thing we could also attach a function, we call it as view. Okay, so let's say, let us declare this as view of -1 and 1. Then we try to put the same thing for the white test variable. Then here we call it as torch.tensor, white test, and what is the data type of the torch.float? Let's say this of 32 bits. And also for this, I'm going to give the view as -1 and +1. Now, this is how you are trying to split the data. This is all about splitting the data set, guys. So this is very much important with respect to the deep learning algorithm. So let me write all over here, or basically comment it out, splitting the data set into training and testing. Now it's time for us to define the linear regression model. So for that purpose, what I could do is I would try to go into the next step, and let us declare a class of linear regression model where we are going to import the NN module. So let's say class all over here, and let's say this is a linear regression model. So guys, as you can see all over here, this respective class is inherited from NN.module. Now let us try to initialize the constructor. So for initializing the constructor, you could use the def init function, so which says def init, and it takes self as a value. Then here we don't need to pass much of the things like input dimension and output dimension. We could keep it out right now. Okay, and after this we could use a super keyword all over here. So super we use when you try to inherit the thing from the parent class, which is a very important part of the object oriented design. Okay, very much effective in these scenarios. So if you are someone who have very less idea regarding oops concept, I would definitely want you to revise it, or you can watch it on our channel. So guys, in next step, what we are trying to do is we are going to define our respective model. So a little bit of object-oriented design concepts are needed all over here. So you can say I have just created a class linear regression model, which is inherited from the NN.module. And it has already passed in the linear regression model and it's trying to bind up with respective class. So that's why I have used super keyword. And this is a very important concept whenever we are trying to use the inheritance concept. Now we have one more variable all over here, that is linear. So we are trying to add this respective thing, self.linear equals to nn.linear, and we are trying to put 3 and 1 as the respective parameter. Means the input features all over here are 3, meaning the size of the rooms, the room, and the age. And 1 is the dimension of it, so we can do it all over here. Now after this, I am trying to initialize one function called forward. I pass this respective self as we are binding this to this class, so we have some reference related, that's why self is here. Now we pass into the x values in this, and we are trying to return self.linear, and then this respective x value we are trying to return. Now after this, we are trying to initialize the model, define the loss function, and also the optimizer in this scenario. So let us declare the variable model all over here, and let's this assign to the linear regression model. So this is a very basic way of initialization. Then we are trying to do some of the mean squared error calculation. So I'm going to use a loss function, and this library is already equipped with ms loss function, the mean square error all over here, which is going to detect the respective error on our given let's say algorithm that we are trying to use. And if you are trying to look for a gradient descent, which actually tells us how much close you are to the prediction, for that purpose I'm going to use optimizer. Now how do you create an optimizer? So you have to use torch.optim and search gradient descent, which is the SGD, and then you have the respective model parameters all over you are going to have. Then we are trying to put some of the learning rate all over here, and this we can say, okay, the learning rate is pretty much slow, so we can take it up as 0.50 and 1. After this, guys, we have a very important task of training the respective data. So for that, I'm going to create an epoch. Let's say this is 1000, and we're trying to iterate through this respective variable that I have introduced for epoch in range. And let's try to pass the epochs. And here we could add model.train. Now let's try to do some prediction. So y prediction model x dot train, compute the loss equals to criterion, y predict y train. So with the help of criterion function that we are trying to use, that is going to help us to compute the respective loss function. Then you have the backward pass, or we can say the gradient descent calculation. And for that, I'm going to use a respective optimizer that I have already declared all over here. Let me show you guys. You can see in this one scenario, we have the optimizer class. And for that purpose, what we could do is we could add it up with torch.noGradient. And for the ypred test, what I'm trying to do is I'm trying to actually predict. So all over here, I'm trying to put model x test. Then I calculate the mean squared error on the test data, so which is done using the criterion function, add y prediction, test and y test data. Okay, and then we could calculate it with the help of the lost item function, which is already inbuilt to calculate the respective mean square error. Now after this, you have to visualize the result, which is very much important, guys. So you can use the scatter plot, x label, y label, title, and show. So let's say this becomes y hyphen test dot numpy, y prediction test dot numpy, and in this respective label that I'm trying to add, x label, y label, and dot title, I'm actually adding the respective names. Let's say this be predict actual houses, this be predicted houses, and this is actual versus predicted house prices. So there are three different parameters that we are trying to target. So guys, after that, we created this respective class of linear regression model, which is actually inheriting from this respective NN module from PyTorch. And let us initialize our respective constructor, and you can see I have used the super keyword. Now, object-oriented design is very much important concept, and OOPS is one of the most fundamental parts when we use these kind of libraries to incorporate these kind of things, because there are a lot of libraries actually written in Python to actually formulate these kind of algorithms. And for you to simplify these things, in order to devise algorithm like this, I would suggest you to revisit OOPS algorithms. And OOPS consists of inheritance, encapsulation, polymorphism, abstraction. Now, these are some of the most basic and the fundamental concept in the programming approach. And you can see their application are already laid down all over here. Now, you can see here, I have included self.linear, and I've used this NN module all over here to create the input feature of 3x1. And you can see there are three input features. For example, the size of the room, and number of rooms, and what is the age of room. So we are taking these three parameters into the consideration. Now let us formulate a function called def_forward, where I will incorporate self as a parameter, where this self is a variable where this is used to take into consideration that the given variables that I've used in this program are binded to this respective class. So this is one of the fundamental concept of the OOPS design. And let's say I pass this respective variable x, and I'm returning into the linear format and use a linear function all over here called x. So this is how I'm defining my respective linear regression model. And this is a very set template, guys. Once you use it, you have to use something like this always if you're trying to implement linear regression algorithm. Now, if you go to the next step, what you are trying to do is you are trying to initialize the model, define the loss function and the optimizer. So these are the respective important parameters whenever you are trying to create any predictive model, because just trying to predict it will not do anything, because you have to also assess your model, how well your model is performing, what are the loss function in the accuracy, whatever you are trying to do, and how your optimizer is. So there are a couple of optimizer that you have, like stochastic gradient descent optimizer, SDG, which we generally use it. And with the help of this, we actually assess how our respective optimization could be done based on the errors that we are receiving, in the accuracy of prediction. Now, after this is very much important for us to actually calculate the mean squared error. So this is nothing else. This is a mathematical function, guys. Let me explain you what this exactly is. So let's say this is your given value, or the given value given by your model. So we call it as yi, and we can also take it as a predicted value, and we subtract it from, let's say, the actual value. Okay, and so we can call it actual. I can be called as prediction value or the predictive value. And what we try to do is we try to square these things. Okay, and after squaring this, taking a square root of these respective value and divided by the number of parameters or number of the training data that we have. Okay, so let's square it, and let's divide it by the number of or we can take the sample size all over here, or basically call it as n, and we take the square root of this. Okay, so sqrt of this respective function, then this is actually equated as mean squared error. Very basic fundamental statistical concept, guys, and which we actually incorporate because deep learning, machine learning, all these predictive algorithms that we are trying to do, these have arrived from all statistics. So very much important in this regard. Now, then what we are doing is we are trying to evaluate our respective model. But before that, let us try to, have a gradient descent initialize also. So let's calculate this variable called optimizer, where I am importing torch.optim, and you can see SGD with the stochastic gradient descent. So this is the respective optimizer which will help us to optimize our respective algorithm that we are trying to use based on the data set. And after this, we are training the model. Let's say the epochs, or the number of iterations, equals to 1000. And for epoch in range of epochs, this is a for loop. I'm trying to train those respective values. Very basic for loop, guys. And I call this a respective model dot train function, which help us to train the respective thing. Then I'm trying to predict the respective model all over here. So I'm passing this model function, and I'm passing this parameter x train all over here. And after that, I'm trying to compute the loss, and the loss is computed with the criterion function. So where we pass the y prediction and y train, the same concept which I actually showed you right now, that how we are trying to calculate this respective thing. So MSRT, if you look into this, we can call it as MSRT, means square root error. And that's what we are actually trying to do. And we are trying to print the respective loss function. And finally, we are trying to visualize the result. What is the deviation from the actual result to the predicted result? And let's say we label it on the X label with the actual prices, Y label with the predicted prices, and then we add the respective title, actual versus predictive, and we try to show the respective visualization. Now let's try to run this thing. Let's see what is our respective output. So you can say we are getting the loss all over here, 2.44, 0.3318, 54.00 based on this respective algorithm. And for each epoch, it is going to run. And you can see our visualization is being plotted, like how, we are trying to give. But you can see in this respective code, what I'm trying to get is, I'm not getting any graphs all over here, because something we have missed out. We are not trying to actually show the respective values. So let us correct that first. Now, guys, there are a couple of changes I did. I actually imported matplotlib inline all over here. And you can see while visualizing the respective data, what I did is I just used a NumPy library to flatten it into a 1D array. Then also the prediction I also added to the 1D array. And majorly the issue was coming on the plotting the scatter graph all over here. And, I used the matplotlib library. So all over here, this goes plt.figure. Then I added some fig size to 8 and 6. Then I scattered it. Based on this, I did some prediction based on a test value and the prediction value, and I added some color for the same representation. Now I added a line all over here for the actual prediction, which actually idealizes the thing with y equals to mx plus c. So you can see all over here, what is the color of the line. The color of the predicted line is red. And similarly, I also added the grid lines which were already there, guys. So for showing the plot, plt.legend, plt.grid true, and I'm trying to actually show the respective output. So you can see this respective line is our predicted output. This is the ideal line that we had, and this is the respective thing all over here. So this is a pretty interesting curve for a linear regression, and this shows what is the exact predicted line that we should have. Now there are a couple of things we could also accumulate in this, but this is an exact demonstration of how y equals to mx plus c will work. So guys, this was a bit about linear regression and how we can plot y equals to mxc graph to predict our respective output. Now let us try to understand another important concept that is called as neural networks. So now you'd be wondering what exactly a neural network is, guys. So if I talk about a neural network is a computational model which is inspired by the way how our human brain actually processes the information. Now, neural networks are very much important part of the deep learning framework, as they are the fundamental way of learning how deep learning is applied and are used for tasks like image classification, text generation, time series prediction, and much more. So a neural network is made up of layers of neurons, and we call it as units, where each neuron processes the information and it passes to the next layer. So what are the basic components of neural network, guys? The first one that is called neurons, and we call it as units. All over here. So neuron is a basic unit of neural network, and each neuron takes an input and processes it. And also it passes the output to the next layer. And the input to the neuron is weighted, and then the activation function is applied to produce the output. So let's talk a bit about the another parameter. We call it as the input layer. Okay, so the input layer is the first layer of the network that takes in the data. For example, it could take the image, sentence, etc. Then you have something called as hidden layers. Now, if I talk about hidden layer, guys, hidden layers are the layer between the input and the output layer where actual computation is taking place. Then we talk about output layers. Now, output layer is a final layer that gives us the predicted output, such as a class label in the classification task. And if you have gone through our machine learning course, then you would be very much familiar with what are the weights and biases. So these are one of the very most important fundamental concepts all over here. So weights, we call it as something where each connection is between the neuron, how much associated weight each connection has. That determines the importance of each input. And if I talk about biases, guys, so biases are the additional parameter that is added to the weight. sum before applying the activation function. Now, what it does is, guys, it helps the model make better prediction by shifting the activation function. Now, I've talked a lot about activation functions. Let me explain you what exactly activation function is. So guys, activation functions actually introduce the non-linearity to the model. So the kind of curve which we're seeing in linear regression, we don't want that kind of curve, because in that's kind of some of the problems can be solved with that. But there are certain problems like image classification and text to speech conversion. For that, those kind of models will not work at all. So activation function introduce these kind of non-linearity, which allows a network to learn more complex patterns. And the some of the important activation functions that we discuss are sigmoid. Okay, so sigmoid, you can just call it as function which takes up the input value, and in the output the value lies between 0 and 1. Okay, so you can think it of as a sine function basically. So if you a little bit think about the mathematical trigonometry, so the sine function takes the value, it could be value from 0 to pi by 2, and the value it gives you is between 0 and 1. So similarly sigmoid is doing, but it is not a sine function, guys. Now, next one is you have a ReLU function, which is a rectified linear unit. This is also some kind of an activation function. So what does it do is, guys, so it outputs 0 for negative inputs, and whatever the input you give it for all the positive value is going to give you the respective input as itself. So this is one of the most important activation function here. Then we have something called as tanh. Now guys, what does tanh actually do is it outputs the value between -1 and 1. So that's some kind of a tan function. If you would have a little bit studied about trigonometry, then you would have got a brief idea regarding this. But even if you don't know about it, it's all right. Understand this as a function which takes up the input value, and it's going to give you the value between -1 and 1. And then you have something called as softmax all over here. Now, what does a softmax do? Basically, it is used in the output layer of a multi-classification problems, and it converts given inputs into probabilities, basically values between 0 and 1. Now, guys, you'd be actually wondering how neural networks actually works. Okay, so let me write it for you. So neural networks, what it does is it follows the principle of forward propagation, where input data is fed into the input layer, and then the data is passed through the hidden layers. And each hidden layer, the input are weighted and summed. Now, in this given process, a bias is added to the weighted sum, and an activation function is applied to result to basically introduce the nonlinearity. And finally, the process data is passed to the output layer, which produces the final prediction. Next step, what we actually do is training the given neural network. So first step, as we discussed, was forward propagation. Now, similarly, we have something called as backward propagation. Now, if I talk about the backward propagation or the gradient descent, okay, so we can replace this with backward propagation technique. Now, during training, the goal is to minimize the loss function, means the mean squared error for the regression, or you can use a cross entropy also loss for classification based problem. To do this, we actually use the backward propagation technique, which is the process of calculating the gradient of the loss function. Now, with respect to each of the weight. So we use the chain rule of calculus all over here. So you have the gradient descent algorithm, which actually is an optimization algorithm that updates the weights to minimize the loss function. And we update the weights by subtracting a fraction of gradient, which is called as the learning rate. Okay, so you can just remember something as LR as one of the parameter, which you would have also seen all over here in our previous programming that we were doing. Now, let me show you how we can create a simple feed-forward neural network, let's say to classify images from MNIST dataset, which are basically the handwritten digits, basically from 0 to 9. And let me show you the MNSIT dataset, guys. So if you look into this respective dataset, you can get it from the Kaggle all over here. So in this data set, what basically you are having, you are getting digits somewhat like this. And let's say if I give you a task to classify these data sets, like for example, what number is it, like which is 1 2 3 4 5 6 7 8. So from this handwritten digits, in order to classify that, we actually use a deep learning algorithm to process that. Now let us say we create a simple feed-forward neural network to classify images from this MNIST dataset, which are handwritten digits from 0 to 9. And the dataset has 28 cross 28 grayscale images. And let's say we have the 10 classes all over here, one for each digit. So we could define a simple neural network, guys. So let me show you how we can define it, and then with one hidden layer below it to explain all these respective things that we are trying to do. So first of all, we'll be using the PyTorch library, guys, as I told you earlier. So what you can do is you can import PyTorch as n. So let us see the respective code, and let's use this. Okay. Now, after that, we could import Optim, which is basically the optimizer. Then we can import a data set and also transforms all over here. And we have to also import the data loader all over here. And after this, what we are trying to import is we are trying to import Torch Vision all over here, where we are importing the data set and the transforms. Now from the Torch utils data, we are also importing the data loader all over here. So which is kind of a very much important for us to carry out this respective task. Now guys, let us take a case study where I'm going to create a simple neural network for classification problem. Now, when I'm trying to create a simple feed-forward neural network to classify images from MNIST dataset, which are basically the handwritten digits that I showed you earlier. And these dataset have 28 cross 28 grayscale images and have 10 classes, one for each digit. How do we start with this, guys? So let us import first one of our most primarily libraries will be required for this process. So you have Torch, then we have imported the NN module, we have imported Optimizer from PyTorch. I've also imported Torch Vision also here, and from that I'm importing the datasets and transforms. And finally from torch.utils.data, I'm also importing the data loader. Now, what is happening all over here? First of all, let us load the MNIST dataset. So let us create one variable train set all over here, which equals to dataset.mnist. And I have given the path as root equals to data. Let's give it as the training equals to true. And then the download process also equals to, and transform equals to transform. Then similarly, I have done it for the training the loader. This variable train loader I have created. Now after this, let's say I have this data loader given variable all over here, and under which function of data loader I am passing the train set, what is the batch size, and what is shuffle. So basically what I'm doing is I'm creating the mini batches of 64 images based on these respective parameters. Now guys, you'd be wondering what exactly is data loader. So data loader is a utility to load dataset into mini batches, and it improves the training efficiency all over here. Now guys, at this step, what I'm trying to do is I'm trying to define a transformation for images. So here you can see all over here, the respective variable here is transform, and I'm using transform.compose, and then I'm converting images into tensors. Basically, these are the numerical representation where you have the numbers represented in the form of zeros and one. And finally, I'm converting these images all over here, and we are trying to normalize this respective thing. So you can see I have used a normalization parameter 0.5 to 0.5. Basically, the pixel values, what I'm trying to do is I'm trying to normalize. Now guys, as you can see all over here, I have this respective transform.toTensor function. Basically what it's doing is it's converting the image to a tensor, which is basically 28 cross 28 image that becomes a 2D tensor of this respective shape 28 cross 28. And then I'm using the normalize function, which is normalizing the pixel values between -1 and 1. Now this helps the model converge faster during the training. Now after this guys, what I'm doing is I'm trying to load the MNIST dataset. So you can see all over here, here I have basically declared this respective value. So as I have told you earlier also. So in this, if I'm actually putting train equals to true. So if you could see this respective parameter. Now what this is going to do guys, this is going to load the training dataset, and similarly the download equals to true downloads a dataset if it's not already present. And when I'm putting transform equals to transform, it actually applies the transformations. So what's happening all over here is that we are trying to do a conversion to tensor, and then we are trying to normalize each image. And finally, we have the data loader function, which takes up, the data in mini batches of 64 images at a time. And while putting shuffle equals to true, we are trying to ensure that the data is randomly shuffled before being fed into the model. Now, after this, guys, I'm defining my neural network architecture. Now, this is one of the most important part of our respective application. So, where what we are trying to do is we are trying to do an object-oriented design, which I have already shown you. So let us create a simple class, let's say simple neural network. And here I have used, let's say, the NN module all over here. Now, what it is doing is, guys, it is defining the simple neural network model by subclassing the NN module. Basically, I'm inheriting from all over here the NN module from the PyTorch. Now, here is a constructor, and in the constructor, if you could see, it initializes the layers that I'm using. So if you could see FC1 and FC2, so these are the respectively fully corrected layers that takes up the input image. Okay, so FC1 is taking up the input image. It flattens to the vector of size 784. It transforms the input into 128 neurons. Now, let's say there is FC2, fully corrected layer 2. Now, what is happening? The output layer is transforming the 128 neuron into 10 output neuron corresponding to the 10 classes. So there is between 0 to 9 that we have seen in the MNIST data set of the digits. Now, if you could see also, there is a function that I've created, basically def forward, and I'm passing self as one of the parameter and x. So this is actually defining the forward pass where the data is passed through the respective network. Now, if you could see, I've also declared x equals to x.view, and the values passed are -1 and 28 cross 28. This is basically the process of flattening, where I'm trying to flatten the input image from a 28 cross 28 matrix into a 1D vector of the size 784. Then I'm activating my activation function, which is a ReLU function, which I've already told you. So this is actually applying the ReLU function, and which is trying to do it after the first fully connected layer. So why we are doing this, that's a one good question you could ask to yourself. The only reason why we are doing is because this is actually adding the non-linearity to the model. And finally, all over here, what we are trying to do is we are trying to apply it to the output layer, let's say self.fc2x, so which gives the final predicted values for each class. Now, finally, in the step 4, we are initializing the model, the loss function, and the optimizer. Now you can see all over here, I have initialized this. So let's say this is the model. This is simple neural network. Okay. So then this is the respective thing that we have created from this respective class. So that's the only thing that we are trying to do. Now you can see there is something, another important thing, if you could clearly notice, there is called criterion. Now which is equals to nn dot cross entropy dot loss. So what is this, guys? This is a cross entropy loss which is used for multi-class classification. It is comparing the predicted class probabilities with the true labels. And after that, I'm putting the optimizer value, which I'm using through optim.adam. So Adam optimizer is there. And you can see the learning rate I have used is 0.001 in this given thing. Now, Adam Optimizer adjusts the model weights based on the gradients during backpropagation, and it is used to minimize the respective loss. Now, in the step 5, I'm trying to train the model till 5 epochs. So let's say epochs equals to 5. So this is the respective for loop for epoch in range epochs. So the loss is, let's say, initially initialized to 0.0. Now, guys, in this epoch, what I'm trying to do is I'm trying to iterate through these epochs, and basically through 5 epochs. And for I and putting up the input and the labels, I'm trying to enumerate. And after this, guys, you could see optimizer.zeroGrad function I have used. So what is this zero grad function? So this clears the gradients from the previous iteration before calculating any new gradients. And in the outputs, if you see all over here, then what we are trying to get is I'm trying to take the respective input by the model and do the forward pass by passing the input images through the network to basically get the predicted labels. So this is very much important. And after this, you could see there is a loss function which is declared, which is equals to criterion. And I'm trying to compute the loss all over here. So loss is calculated actually by comparing the model's predicted labels, which is the output, with the true labels that we have declared all over here. Then you can see I have used this function loss.backward. So this is performing the back propagation step, which I discussed with you, where the gradients are calculated based on the loss. And finally, I'm trying to put optimizer.step, which is trying to do what the optimizer runs, and it updates the model weights using the computed gradient. Now, this is how I'm actually training our neural network. So what is happening, guys, under the hood? The input data, which is basically the images, which is passed through the network, and the model is able to make the predictions. These predictions are compared with the true labels using the loss function. The optimizer is updating the weights based on the gradients calculated during the back propagation. And this process is repeated for several epochs until the model is converging and performing well on the respective data. Now, at this, you can see I'm trying to use the if and else condition. If I modulo 100 equals to 99, so I'm basically, what this is doing is I'm trying to print every 100 mini batches all over here, and I'm also calculating the loss all over here. So this is kind of very much important. So in a nutshell, guys, neural networks are trained in this way, and this is the respective template what you could use with the help of PyTorch. So I'm actually using a pre-loaded data set, the MNIST data set all over here, with the help of which I'm trying to actually create one neural network. Now, neural networks, as I've already told you, are the building blocks of deep learning, and they are used for a variety of tasks, especially when the data has complex pattern. Now, in this scenario, we have used a simple feed-forward neural network to classify this MNIST images, which are basically the handwritten digits, into which is 1, which is 2, which is 3, till 0 to 10. And the forward pass involves passing the input through the network layers and training the process, and also adjusting the weights to minimize the loss using back propagation and gradient descent technique. So this was a bit about our respective neural network, guys, and I hope so you would have got a brief idea regarding the same. Now let us try to run this and see our respective output. Now guys, you can see that our respective model has tried to create the respective loss, and it's trying to calculate this. And initially it's giving 0.890, 0.436, and you can see the optimizer that I am trying to use all over here, Atom Optimizer, it's trying to reduce the value. Initially the loss was very much. After iterating couple of times, you can see the loss here which I have calculated is getting reduced from 0.82. You can see the value is going to 0.1, and it is still going to get continued, and you can see this is going to happen till 5 epochs. So till then our respective given function is going to run. Now I hope so guys you would have got a brief idea regarding neural networks. Now let us move on to the next part of the algorithm, where we are going to explain the CNN algorithm and try to understand how deep learning applies all over there. Now guys, we have got a brief idea regarding convolutional neural network. So let us try to explore what exactly is CNN. So if I would say that CNN is also a very important part of deep learning model, which is primarily designed for image processing task. But it is particularly effective for tasks like image classification, object detection, and image segmentation. And the CNN algorithm automatically detects features in an image such as edges, textures, and patterns without needing the explicit input from humans. So convolutional neural networks actually work using something called as filters. We can also call it as kernels that convolve across the input image to capture the local patterns. And these features are then progressively combined and passed through deeper layers to detect more complex structures. Now, you can ask me this question, that why CNN are good for images? See, images are actually considered as structured data, unlike regular data where features are independent, like your tabular data. And images have a spatial structure, means pixels in an image are related to one and another, and CNN leverage this spatial structure. Also guys, in this you have a parameter sharing also. In CNN, the same filter or the kernel is used for all parts of the image. Now this means that instead of learning a different set of weights for each pixel, the model learns to detect specific features across the entire image. For example, like detecting edges, regardless of where they are. Then you have the local receptive fields. Now, what are local receptive fields, guys? Let me tell you, this is one of the most important terms. Now, instead of looking at the entire image at once, CNN focus on actually called as local regions, or we can also call it as the receptive field. So which helps in detecting simpler features such as the edges and the textures that are later used to recognize more complex pattern. Now, we are going to do one case study with the convolutional neural network. So we'll try to do image classification with CIFAR-10 dataset. Now, to understand this algorithm better, let us walk through some real case study. So let's say our given task is all over here, that let's say we want to classify the image. Okay, and into let's say 10 categories. And let's say the categories could be, for example, it could belong to aeroplane, it could be cat, it could be dog. So based on seeing the images, we have to classify, all these respective objects that is visible in the image, and that you can easily get it from the CIFAR-10 dataset. Now let me tell you something about this respective dataset, guys. What this dataset is actually all about. So this dataset actually contains 60,000 images of size 32 cross 32 pixels and across 10 classes. For example, let's say we can have one class 1 aeroplane, then we can have one class 2 called as dog, one class 3 as cat. Now, what is our goal at the end of the day? Our goal is to build a CNN model that can classify these images correctly. Now, there are some of the important concepts first in CNN algorithm. Let us try to uncover that first. Okay. So, if I just talk about the key CNN concept, guys, so there are a couple of them. First of all, if I just look into this, the thing which comes into my mind is called as convolutional layer. Now, what is this convolutional layer, guys? So, convolutional layer is basically a function that detects simple features like edges and corners. Then you will also be dealing with something called as operation. Now, what is this operation, guys? This is basically a filter or a kernel that slides over the image and applies the operation at each position to detect the patterns. So this is also kind of very much important. And next we have something called as kernel size. So what you do, guys, with the help of kernel size is that you define the size of the filter. Maybe it could be a 3x3 filter all over here. Then you define how much the filter moves during each convolutional step. So that is called as stride all over here. So you have to define how much the filter is moving through each of the steps. For example, like 1 pixel or the 2 pixel. Then you would also see something called as padding, guys. Padding is also a very important concept. So guys, what does a padding do? Basically, it adds extra pixels around the border to maintain image size after convolutional. And then you have the respective ReLU function all over here, which is the activation function. Now, what it is doing is all over here that this after a convolutional, the activation function is introducing the non-linearity to the network, which enables it to learn more complex pattern. So you have something called as a rectified linear unit, which sets all the negative values to 0 and keeps only the positive values, and it keeps as unchanged. Now, you will also find across something called as pooling layer, guys. Now, what is a pooling layer? So this is also a function, we call it as max pooling basically. So this is a function which reduces the spatial dimensions of the image, which makes the model computationally efficient, and you don't come across the overfitting problem all over here. Now, there is something also called as max pooling, guys. So if I talk about max pooling, so max pooling is also very important deep learning concept with respect to convolutional neural network, which takes the minimum value from each patch of the image. Let's say it could be 2x2 region all over here. Then you have something called as dense layer or the fully connected layer. Okay. So guys, after several convolutions and pooling layers, the image is flattened and it is converted into a 1D vector, and it is passed through the fully connected layers to make the final classification. Now, these are some of the things that we will be using in our respective problem to understand this. So let's try to begin the respective formulation, guys. Now guys, our first step is same. You have to install the necessary libraries. For example, you have to have the NN module, you have to have the optimizer. Then you have to torch vision, from where we are importing the dataset and the transforms. Then you have the data loader all over here. So you have torch.utils.data, where you are trying to add the respective data loaders. Now, this is basically Delta as PyTorch, which is one of the core library for creating neural networks and processing the respective tensors all over here, which is a multidimensional array, if I tell you. Then you have a PyTorch, which is the code library for creating the neural networks and processing the tensors, which are multidimensional arrays. Then you have the torch.nl module, and this module is containing the building blocks for neural networks like the layers, the loss functions, and all those things, which is basically providing the optimization algorithm like Adam and stochastic gradient descent to adjust the weights of the respective network. Then you have the respective Torch Vision library all over here, which is providing the utilities for working with image data, and it has something inbuilt data, which is CIFAR-10 dataset. Now, in the step one, what we are trying to do is we are going to try to define the transformation for the images. So let us say all over here, okay, let's mark this as step one. Transformations. Okay, now same thing guys that we did earlier. So here you have to use transform.compose function as we did while creating the neural networks. Now after this you have to convert this to the tensor value. You have to convert the image to a respective tensor, which is basically the numerical transformation, and after that you have to normalize this respective values. Now here's something I'm going to change it. Okay, so you can add these respective values guys. Let's say this is 0.5, this is also 0.5, and we can also treat the next parameter as 0.5. So what we are trying to do is we are trying to normalize the pixel values such that our given thing comes in between -1 to 1. And this transform.compose function combines the several image transformation into a single pipeline. And if you could see the two tensor method that we have all over here, it is converting each image to a tensor which is needed for processing in PyTorch. And then the image is transformed from the 3D array. For example, you'll have height, width, channels to a 4D tensor with the batch size and with the height, width all over here. And then you have this normalized function all over here, which is scaling the pixel values between -1 and 1. Now what it is doing this is helping in speeding up training and making the learning process more stable. Now, in the step 2, let us try to load the CIFAR dataset and to categories like cats, dog, etc. Now guys, if you could see all the way here, I'm trying to load the CIFAR-10 dataset, which is loading from the Torch Vision library, and a root you can see I have put this into ./data. Now this is specifying the location where the dataset will be stored, and also you have this train equals to true, download equals to true, and transform equals to true. So these are the things we are actually going to do. If I'm setting it to true, basically it means we are loading and training the dataset. Then if I'm trying to put download equals to true, we are downloading the dataset if it's not already present on the disk. Next thing, what I'm trying to do, I'm trying to put transform equals to transform. For example, here I'm trying to apply all the normalization thing which are applied to each image. And then you can have this respective data loader where I'm trying to put the training set, the batch size, and I've put shuffle equals to true. Now this is loading the data into mini batches of 64 images, and it shuffles the data to ensure that the model doesn't learn based on the order of the images. Now, the next step will be very much important for us because here we will be defining our CNN architecture. And you already know a template, guys, as we have done it in the neural networks. So this is where your object-oriented design is going to come up. Now, guys, the same class name I have used, CNN, and I am inheriting it from the NNN module. Now this is our constructor, and I am trying to actually pass this given class name all over here, which is CNN, and trying to inherit all the properties which already have present in the NN module. Then you can see we have something called as conv.1. Now what is conv1? So this is our first convolutional layer that processes the input image with 3 channels, and the 3 channels are red, green, and blue, and it outputs the 32 feature maps with a kernel size of 3 cross 3. So that's kind of pretty interesting because we'll be using padding equals to 1 to ensure that our output remains the same. So guys, this is the first layer that I'm using for the first convolutional layer. Then you can see I have the next something I've done the max pooling. Whenever I'm trying to do the max pooling, it is trying to reduce the image size by selecting the maximum value from the 2x2 region, and that's why this is called as max pool. Similarly, guys, you can see all over here we have the second convolutional layer, and here it's of 32-bit size, and kernel size equals to 3, padding equals to 1. Now, what this is trying to do is, this is the second convolutional layer, and it's trying to process the output from convolutional layer 1, and it is generating a 64 feature maps. And then after that, what we are trying to do is we are trying to create a fully connected layer, okay, of 64 class 8x8, basically of 128 size. So your FC1 and FC2 are the fully connected layers which take the output of the convolutional layer and make the final prediction. Now, the same thing in the next architecture is I have created a feed-forward network all over here, and I'm applying the ReLU function all over here and trying to do the max pooling. So let's say x equals to self.pool and nn.ReLU self.conv1x. Then I'm applying the convolutional layer 2 and trying to do my activation function x self pool nn.ReLU. Then I'm trying to flatten the image for the fully connected layers, where I'm trying to put x.view with -1 64 cross 8 cross 8. And then after that, I'm applying my first fully connected layer all over here. And you can see after this, I'm storing the value as x, which is our final output layer, and which will do the respective classification. So this is how our feed-forward neural network is working based on the convolutional layer 1, convolutional layer 2, and we are trying to apply the max pooling technique. And with the help of ReLU function, I'm trying to put the values between, let's say only taking those values which are positive and rest putting it to 0. Now, in the step 4, what I'm trying to do is, guys, I'm trying to initialize the model and our loss function. So let's say this is equals to model is CNN, instantiating the CNN model. Then I'm using the criterion as the base for declaring our loss function all over here. So which is actually used for multi-class classification problem. It actually calculates how far the model's prediction are from the true label. Then you have the respective optimizer, and you're using optim.atom, okay, which is trying to update the model's weight based on the gradients during the back propagation. And in this step 5, what I'm trying to do is I'm trying to train the model for 5 epochs. So let's say for epoch in range of epochs, running loss equals to 0.0. And for epoch in range of epochs, I'm trying to declare this running loss equals to 0.0. And after this, there is a for loop for I input and labels. We are trying to enumerate this, and then I'm trying to put optimizer.0grad, applying the 0 gradient before the backward propagation, and then I'm trying to do the forward passing all over here, and I'm also calculating the loss function all over here with the help of criterion, where I'm trying to add the outputs and the label, because those are the thing like how is our output we are getting and how we have wanted our model to behave. That's kind of the ideal value. Now, if you could look all over here, I have put optimizer.0grad. This is kind of a same template that was used for declaring our neural network. So it clears the gradients from the previous iteration. And finally, what I'm trying to do is I'm trying to create variable outputs all over here. And this is basically doing what this is taking the input image and this pass through CNN to get the predicted labels. Finally, guys, I have this loss.backward function. So what this is trying to do is it is trying to do a backward pass to compute the gradients, like how much each weight is contributed to the loss. And finally, we have optimizer.step, which is doing what, guys? Which is actually taking the optimizer to update the model weights using the gradients, and it is computed during the back propagation technique. And finally, I am just using a for loop to actually print out what are the laws in the respective epochs that we have declared. And the epochs are 5 epochs. Now, this is our respective code, guys. Now let us try to run it and see what happens. So guys, let us try to run this thing and let us try to see what's happening all over here. So you can see it's trying to first try to install all the respective libraries all over here. And it might take some time to follow up with the execution process. Let us wait. Now you can see for the first epoch, it has generated the respective laws based on trying to compute what is the loss function. Then you can see it has also started to give the loss function for the next iteration, and from 1.8 to 1.5, and this process is going to continue. So guys, this is one of the most important techniques where we are trying to do the model evaluation and try to calculate the loss function. So guys, CNN is a very important algorithm which is used for image classification. And when you're working with detecting features like edges and textures through convolutional layers, this is one of the most important algorithms. The training involves passing images through CNN, calculating the loss, updating the model weights using back propagation technique. So this is all we have done here. So guys, this was a bit about deep learning all over here, and I hope so you would have got a brief idea regarding this. Thank you guys for watching this video. If you have liked this video, then do not forget to hit the subscribe button and click the notification bell icon. Thank you guys for watching this video.